What's up, everybody? Just hanging out on my ladder and waiting for batteries to charge and for friends to get back to me. I have notched out the framing from one corner all the way down to the other end. You can see there's the far end. So the ends of these floor joists come over, and the stud and second story sheathing and everything go up, but that stuff is cantilevered off of this beam right now. The joists, the one-piece joists, are sitting on the far end on our new beam over there, and they are standing on this temporary carrying beam, and then they're cantilevered out here, and then they're standing out, and the rest of the stuff is basically settled down a little bit. Maybe I should have stayed up there. You can see this here. This tongue and groove sheathing has opened up across there, and that's basically where it's separated. This piece has mostly stayed up with the rest of the building, and the rest of it has settled down and probably come to rest at some point on the foundation once again. And that's because this stuff is all hanging down. It used to be stacked up, and now it's hanging. We'll get our beam in there, our new beam. Here's a piece of it here, cut and ready. It's got a bracket on the end and a bracket at 128 inches over. And this is ready to, it's going to be fed over that knee and stood up in and then flattened out and packed out tight to the outside of the building. And then we can make another one just like it and put it over those knees and the overhead door and send it in tight to the building there. And then we can add our 16 feet in the middle and our 8 feet on both ends. Marry it all together, go outside and attach the sheathing board into it, and then we can pick up the wall that's hanging from the foundation and make a little location in the foundation to dig and put our posts, and then we'll nail those boards to the posts, which is what's holding them here. These sheathing boards are being suspended by being nailed into each of our new posts only. And in the case of like this piece of wall over here, I nailed some old 2x4s to the beam up there, nailed those in, and then I picked this up and I nailed them into the framing on either side of the window all the way out, or all the way along. So you can see this is just hanging here. But if these 2x4s didn't run up and past that beam and weren't nailed into it, this stuff would all just be falling down. You know, these boards would be tipping over, and the opening for the window would be racking out of square, etc. You may notice the knees. That's what these are called. I had this whole arrangement in here, and it was supporting the weight of the building, and there's a lot of strength there, but you never want to be able to rack. If I could draw some here, you know, if you have a square, it's hard to draw while looking through the phone. There's plenty of strength here, and none of these legs of the shape need to deform, but they can rack over, you know, and take the top over with them. And we're preserving their lengths and their own unique structural integrity, which is to say the beam could remain one solid unit, the post could remain one solid unit, but as a group there is the potential for racking. And the way that we protect against that today in a wall is to create a stud wall, which once again has plenty of strength, you know, when you stack things on it like this. But if you were to push at the top or slide the bottom or both, or anything were to shift, it could rack. So then we put, once we've got the framing done, we put sheet goods on the framing in a running bond, which is to say we send one whole piece past the seam on another, and you know, this one would continue, or it would be a separate piece here, but we cover the surface of it, and then we nail that all up to each one of these sticks, which basically triangulates. Every time you pierce that sheet good and attach it to that frame section, you define the distance from this nail to that nail to that nail to that nail to that nail, and you could run around to every one of those head, literally every nail head or screw head, and you could connect each one to all the nearest ones with a line segment, and those are literally trussing, creating a truss network and preventing that system from racking over. Because for that to travel in any way, for this to shift laterally in any way, all of those distances need to change, whether they need to grow larger from one another or compress, and the nails need to come closer together, and that can't happen, of course, because we've got in a cross section you have the plywood and you have the nail, and it goes through into the stud, and it goes through the plywood. Now we can't migrate that nail around. We all, that's being a bit pedantic even, or unnecessarily descriptive, but that's exactly what you're doing when you're covering a system like this, a framing system with sheathing, unless it's old school and it's all matched lumber. Then instead of big sheets with nails all over the sheet that you can triangulate, you've got a system of framing like this with a sole plate and a top plate. But every one of these boards, sheathing boards like this wall has here, you can only have nails in a very short aspect. They can only be this far spread apart. They certainly can be, horizontally speaking, a great distance from one another. But if you were to draw a line through a line of horizontal nails, that could still rack. That system could still rack over. You have a top, a bottom, and this line of nails at that elevation does not have to grow any longer or compress any shorter. It can travel every dimension here. This is geometry, but every horizontal dimension here will remain the same as you rack that thing over, and you could shut it down to basically a flat line in theory, and in reality you could have a pile of framing lumber there. So as sheathing, boards weren't that effective structurally speaking, and so since we haven't got, long story short, since we haven't got big sheet goods on this wall, we haven't got any that we can add. It isn't in the program here. It's not part of the project to cover the inside with plywood, which we could rely on for that. What we're going to do is put in a knee, and that will control in our new wall system. Boy, am I making a mess of this piece of lumber here. But in our new wall system, to prevent that from racking, we have simple triangulation. And we'll keep going here, and this one will have a pair, and this one will have a pair, and the last one over there will have one. But that controls this at 90 degrees. And to take the bottom of this stick that direction would require this knee to grow in length and this one to shorten, and vice versa, for this one to grow in length for this one to shorten, and it will not. It's rigid. It's been sucked down tight with some of these real large lag equivalents. Variety of manufacturers. Simpson makes these, Fasten Master makes these, depends on where you go shopping, and they have different head styles. That's a big ledger type head with a proprietary 8-point kind of Torx drive on it. This is more of a conventional hexagonal socket head, but they run in like any other screw would run in with a nice heavy-duty drill gun, but it just goes brrr. You don't have to pre-drill a hole, nothing. But for their diameter, they're actually equivalent to a larger diameter lag bolt. You don't need to pre-drill a hole, and you don't need a wacky driver setup with a socket or anything like that. This is just a small hex, so you can put a socket tip all one piece in. These are relatively expensive, but a framer and timber framer and structural specialist's best friend. In fact, there's a bunch of different reasons to familiarize yourself with these, but this is how we're doing these. We found the middle of this side. This is basically 8 inches. We found 4 inches in the middle. We threw the square on at 4. We took that measurement over to the side, and then we threw a line across, and we measured and found out that was 5 3/4 of an inch. So we just pulled the tape on the ends of the knife end of all of these at 5 3/4 of an inch, made a line, and then we measured in from the edge 1 inch over, 1 inch over, 1 inch over, and made a line there. And then I just took my Forstner bit. I had them set up here, using the table to make them normal to me, and I would just start at the marked hole, and once I got started cutting, I just tipped the drill up until I was vertical, and then I went down until the bottom of that Forstner bit kissed. I got a full circle out of it, and then I could be sure that basically there's a flat circular plane normal to the flat end of each of these knees, and then I just started one of these screws in, so I could take the thing, 1 unit, screws in it over to the wall, place it, and then dial it in a little bit. You know, if you may have to hit it with a dead blow hammer or hold it with a clamp or run one of them in and then deform it with a bar just to get a nice, you know, smooth surface for installation. But then you get 1, 2, 3, 4 with the big impact gun, and it really takes no time at all. I made all the pieces as an assembly operation here on the miter saw, and then I went and did all the whole layouts together. I put all the screws in together, and then really I could break this stuff down and, you know, just do the installation as a last step. So that's where we're at. I think we're going to finish the knees before the weekend, and if we can get some help, we'll put in the beam. Hurry up and wait, as usual. One-man show. Have a good weekend. Thanks for watching. We'll see you.